All right, hello there, students. This is the second part, and it's going to be a short video, hopefully, to section 3.6, which is about compound inequalities. And I wanted to make a quick video about some notation that you can write compound inequalities in. And this is something that you will see a little bit this year and for sure next year in the future. So I wanted to introduce it to you. Um, so we are going to go to this slide down here. And there are two different ways to write inequality. There's actually more than two different ways. There's at least three, four different ways to write inequalities, other than the ones that we've been doing. So I'm going to introduce you to two of them. One of them is interval notation. So what interval notation is, well, you'll be given an example like this to the right here. It says, well, let's look at this problem right here. So what is the graph of that? How do you write it as an inequality? So this is one of the notations that you're going to be seeing. There's a bracket, -4, comma 6, and then a parentheses. So it's kind of weird. Almost looks like an ordered pair for graphing, but there's a bracket on one of the sides. So if we look over to the left here, it's called interval notation. In interval notation, it says use parentheses when either a less than or greater than symbol indicates that the interval's endpoints are not included. So if it would be a less than or greater than symbol, it would be the parentheses. And again, these are for compound inequalities typically. You use the brackets when it would be greater than or equal to and less than or equal to. There's also a couple other things on here. In case it goes on forever to the positive direction, it'd be infinity. So you can do regular inequalities, and they just go on if they like, and I'll use an example. If you have x is greater than or equal to 6, you could write that x would be the endpoint, and since it would be equal to, we'd have the bracket around the x, but that would be 6 would be the endpoint, sorry, and it'd go on to the right. If you think of the graph, it'd go on to forever, so it'd go into infinity. And since it would go into infinity, we would just have a parentheses there. Okay? Now if it go backwards, we can have negative infinity on the left and 6 on the right. But it's going to the right. That's how the graph would be. Because the graph would look like this, you know. You'd have 6, 7, and it's a closed circle going all the way to the right and never going to stop. Right? So if you look at over to the left, before we do problem 5 here, inequality, x is greater than or equal to -2, or 2. So the graph we have right there, greater than negative or equal to -2. Interval notation, kind of like I just did. 2 is the endpoint with the bracket because it's greater than or equal to. And it goes on to for infinity to the right, and that would be a parentheses. Going down, next one, x is less than 2. So this one's just going to be all parentheses because there's no greater than or equal to. This time it's less than 2, so it's going to go on to the left forever. So sometimes it helps to draw the graph. So you put negative infinity because it's going into the negatives for forever. And then the endpoint, which would be an open circle, would be 2. All right? This one is a compound inequality, one that we've seen. It says, and again, if you would break this apart, actually, no, we don't have to. We have the two endpoints. We have, and this is an and inequality. Sorry, a compound inequality. And the x is going to be between the 1 and 5. So our two numbers in there are going to be 1 and 5. And since the 1 has just a less than symbol by it, that would be parentheses, but the right has a less than or equal to symbol, so that would be a bracket. And lastly, here we have an or situation. So we just do each one at a time. Graph them, first of all. And then we're going to have two different interval notations. This left one is going to have -3 in it, like we have here. But it's going to the left forever, so that would be negative infinity on the left. And there's no or equal to in that one, so there's just parentheses. The right one, though, goes on forever to the right, so the right number there is going to be infinity. The left one is going to be the 4, and since it is greater than or equal to we have the bracket on the left side by the 4. So let's look at this one. What is the graph of negative 4, 6? How would you write that as an inequality? Maybe we should write that as an inequality first, maybe not. I think the graph actually will be helpful. If you draw the graph, we're going to have it all the way down to negative 4. You know, we have negative 3, negative 2, negative 1. 0 would be right here. 1, 2, 3, 4, 5, 6 would be right there. So this is how it's going to be. We have a bracket to the left at the negative 4, so that's a closed circle. We have parentheses to the right at 6, so that's an open circle. And it has to be between those two. Those are the two ends. And that's what it would be. Now, to write that as a compound inequality, you can write that a couple different ways. You could write that negative 4 would be less than or equal to x, and x would be less than or equal to, not or equal to, sorry, just less than 6. Or again, you can write that with the negative 4, the 6, and the x, and the correct symbols in between. All right? So that's interval notation. Now the second one is set builder notation we're going to talk about. Set builder notation. This one's pretty basic, actually. It looks kind of weird, and it seems kind of like, why do you have to write like this? But it's a common notation when you get into higher mathematics. So I'm going to introduce it to you. Set builder notation, if you read along with me, is another way to write sets, or inequality sets. It describes the properties of an element uh, must have to be included in a set. For example, you can write the set. So that's a set. That's just saying everything that's included would be 2, 4, 6, and etc. In set builder notation, it's like this. You're using x, and then you have that line divided by, so it's such that x is a multiple of 2. That's all the restriction is. Now we're going to have, in there, we're going to have writing an inequality usually. And that would be read, by the way, it says the set of all real numbers x such that x is a multiple of 2. We're going to do one example here. How do you write the t is the set of natural numbers that are less than 6? So we're going to use these funky brackets, and we're using t as the set. So t is this set. Let's use x as our variable, such that x is a natural number. So we'll say x is natural. So it's dividing up by saying x is natural. And x has to be less than 6. So there it is. That's my set builder notation. And let's check below here to see if that was done correctly. So set builder notation, we use the variable x, and we're describing what x could be. And that's right there. So that's how you use set builder notation. Let's do one more example here. It says, in set builder notation, how do you write the solutions of that? So why don't we solve it first? Negative 5x, so we can figure out what we're dealing with. So less than or equal to 17. Subtract 7 from both sides. You still have negative 5x, so less than or equal to 10. And when you divide both sides by negative 5, x is going to be, negative rho, so we switch the sign. Greater than or equal to negative 2. So that's our inequality. If you wanted to write that in interval notation, you would, let's see, interval notation. We have negative 2. It's going to be greater than or equal to negative 2. So negative 2 is going to be the left endpoint. And it's going to go on to forever into infinity. Since it has an equal to sign, we'll have the bracket, and then on the right side, it'll just be the parentheses. That would be interval notation. Set builder, which is this new one. Well, I guess they're both new. Oops. Set builder, you can write it with the funky brackets. Not sure why that happened there. Funky brackets here. We're using x such that Well, we don't know what x is. It could be just a real number, so we're just going to say such that x is greater than or equal to -2. We could say that it's a real number, but that's what we're assuming. It's all real numbers. So there it is. That is set builder notation. All right, so that's just an introduction to two different types of um, writing inequalities, different notations, and we will be using those from time to time. So make sure your notes are good to go for that. And we'll see you next time.